start out with any questions?
Why am I confused with the word magnitude?
I don't know. I blame childhood scars, but, you know, come with the rest. You have kids, maybe that's doing it to you. Would you prefer size? The math people, I'm gonna blame them on this one. Magnitude is just the word for just how big it is. So size works. Some people, when one of the master sets, use amount, which is probably not the best word, but it works. Trying to think on probably a magnitude for the test, but I mean, that's something like there that if during the test or quiz or whatever, if I use the word magnitude, suddenly your mind's blank, you just say, what is magnitude again? I'll just, it's size amount.
So this is, what is the amount of the total velocity?
Yeah, the number with the units. Trying to think of,
You remember like I was saying before, like if you're doing, force equals mass times acceleration, the way how it's like worded, I guess the forces and everything, it's really like, it's not big, but it's, I think that's where the confusion is at, just the switch of the way the words are, the letters are written.
oh, F equals MA versus M equals, or A equals F over M.
Something like
That's a different issue from the magnitude.
that. Yeah, no,
Okay.
okay.
Or the
It's just- I
or
guess
question
it's
mark
the
at the end.
wording, how things are worded, I think that's what they mean.
Oh.
But I'm grasping it. I'm gonna just think of, like I said, size, and as I got it together.
Glad I could be there for that. Yeah, I don't think I helped at all, but, you know.
Yes, you did, because you said it's just the amount, so like I said, like, it was just a switch of how things are just, how your mind is like, are like set in one way, so you gotta kind of think of it like a different. So, you use magnitude, you just said it's the amount, I'm just like, oh, we just couldn't say that. That's basically what it
Yeah.
boils down to.
Because I hang around really long time. You know, physicists have their own language.
Yeah,
And-
yeah, that's what I'm gathering, yeah.
And unfortunately, I think there's a lot of disciplines where they create their own language with the idea of trying to be clearer, but what it ultimately does is just exclude you. You quickly know whether someone's part of the group or not by the language they use.
Oh my goodness. I looked at the PowerPoint and you went through some and you just like, you know, we just use K equals one of that, and we squared. I'm like, so you just took me through all of that to say, oh, we're lazy, we're not even gonna use all of that. We're gonna use this. I'm like, I don't got time for all of that other stuff.
There's always room for Jello, and there's always time for physics.
I made time for it because it helped me to understand why you guys made, I'm just said, we're just gonna stick to this, because it's all the same wording, but we can condense it into this.
Yeah, the trick, and this is something.
A trick, that's what it is, a trick, you gotta be tricking.
Like a card trick. Whenever you're trying to simplify any topic, it's a question of what do you leave out, what do you leave in, how much you make it sound like it's always true when it's really only true 90% of the time. And so, I mean, if you read the commentary, you know some of the issues I've had with Paul Hewitt. But occasionally I find someone online who's even snarkier than I am, so it's refreshing that I'm not the worst. So there's the So a lot of, we can do some long complex derivations and then come out with, all right, but, you know, for this class, this is gonna work.
That's what I got.
The questions, comments, or concerns? Amina?
Procedure B on the lab, the vector lab. I don't understand how to do this one.
All right, so. Let me, I have a copy right here. All right, so they're given, so the problem is giving 4 vectors. These won't be exactly the same as that, I'm just gonna put 4 vectors down. A, B, C, and, I'll just put it that way, D. And assume that all of them are drawn proportionally correct, like they are done here. The fact that the longest vector over there stands for the longest magnitude or amount, the biggest force. The smallest one is the smallest force. So then they send you through a bunch of exercises. The first one is A plus B. Now, in the lab, there's a grid, there's a faint grid pattern behind it, at least I can see a faint grid pattern here. So you know how far over, how far up you need to go. But on something like this, I just sort of sketched it out here. I don't have it in any specific order here, or they're not necessarily proportional by some factor. But that was badly worded. It's not as obvious how far over and how far up you go in each case of what I've drawn. But A plus B, I take either of these vectors, doesn't matter which one, and I just redraw it. So if I take A, that supposedly is the same length and the same direction as this vector right here. This is my starting point, that's the end. And then I take B. That's A, and then B starts here. That's B. Now we haven't actually solved the problem yet because all we've done is just put, you know, A plus B is, well, that's what A plus B looks like graphically. But the answer, from where you begin to where you end, so my resultant, that would be A plus B.
Can I ask a question?
Okay?
Wouldn't it be switched around the arrow the other way?
This one?
Yeah.
No, it's definitely, it's from where you begin to where you end.
Oh.
Let me do it slightly differently. It hopefully becomes a little bit more clear about why you would do that.
Okay.
I guess conceptually, if you think about this, like think about forces. For example, if I have an object here and I'm pulling on it in that direction, and then I'm pulling on it with that direction, which way is the total force going to be? Not directly, it's somewhere closer to that than that, but somewhere over here. In that direction. It's not going to be the opposite.
All right, so you don't have to worry about, so the resultant is not necessarily tip to tail. It's just.
The resultant would be the first tail to the final tip.
Okay.
Another way of looking at it for you algebra fans out there, if A here, so let's just set up some sort of system, since I don't have grid marks. So if A is, let's just say 4 over 3 up. So if this is 4 to the right and then 3 up. And again, I hat and J hat is just shorthand because I don't feel like writing to the right and up. And then B, we'll just say it's 1 to the right and then 2 down. So assuming that these are correct about how far over, how far up or down. If I add them, that's just going to be 4I hat plus 3J hat. that's A, plus B, which is 1 I hat minus 2 j hat. And then you add like terms. I got 4 i's here and I got 1 I there, I got 5 i's. I got 3 j's here and minus 2 j's here, which is the total of 1 j. So that's my resultant. It's primarily to the right and a little bit up. Not exactly what I'm showing right here, but that's partly because I can't draw. I think my A is slightly wrong. I might redraw. Which is fortunate that they gave you a grid so you know exactly how far to take it. All right, so there were 2 questions out there. So, Brittany, your question was answered. And
I understand, so that's for the addition part. What about the subtraction part? Like it says A minus C.
okay. So if we do A minus C, all right, the negative just means the other way. So C is going to the left. Negative C would be the same length, just opposite direction. So if I treat any subtraction as just adding a negative, that's the same as A plus negative C. So one way to do it is I've drawn out A, and again, pretend, I think I'm getting worse and worse there. I like a board that can erase, unlike in the other room. However, the advantage of the other one is I can make marks in the board with my finger and I can see them afterwards. It's hard to see it here. So that's A plus negative C. So C was that way, negative C is this way. So that's A plus negative C or A minus C. Or, there's another way of doing the exact same thing, but Luis, a question on this one?
Yeah.
Okay, yes.
So, if A was negative, the arrow, well, would it be pointing downwards instead of upwards, right?
Yeah, down and to the left.
Okay.
Okay. Alternatively, I could just draw A and C tail to tail. If I'm doing a subtraction, I want to figure out, subtraction is just difference. What's the difference between these two? So I draw them down with something in common. So I draw my A, and pretending I can maintain some sort of color coding here. So I draw A and I draw C. And the difference is, well, basically head to head. And I typically don't do it this way, but this is just another way of looking at the same thing. If I say A minus C is equal to some resultant, that means that A is equal to that resultant plus C. Just adding C to both sides. So the question is, if I take C and I add a resultant to it, I need to get to A. So that would be my resultant right there, which is pretty close to what I had right there. Isn't math fun? Yeah. The advantage is that you have multiple ways of looking at it. Unfortunately, sometimes students in a moment of panic start mixing and matching techniques. It doesn't, mixing and matching techniques does not always work. All right, so I guess, Amanda, did I answer your question?
Yes, sir.
Okay. Any other questions about this? Any other questions? Yeah,
Could
Tanner?
you use the diagram theorem to install these as well, or would you just have to use the I-hat and the J-hat? Like if you were.
It depends on what they're asking. Let's see, for this particular problem, I would stick with I hat, J hat, or I think on this part, let's see. Yeah, so for this particular procedure B, all you need to do is have a drawing of the resultant. You don't actually have to give
Okay.
numbers.
Okay,
But if you gave numbers, I would define I hat, J hat, and then do it in that term.
got it.
So it's technically polar form, and I know you said you got it, but I'm gonna keep going. Technically, if you're doing polar form where you wanted the magnitude, you'd also have to give the direction in terms of the angle, and that's beyond the scope of the course.
Got it.
If you can do it, more power to you, but not required for the course.
For
Lydia?
procedure A, do you want, like when we fill in the charts, for positive, do you want us to put positive, does it matter?
Sorry, for which problem?
Like, so for problem one, when you fill in the little chart in procedure A, sorry.
Okay.
Do you want us to put like positive, I know we have to put negative, but do we have to put the positive too? Like plus two or whatever?
Yeah, I'm assuming that positive is to the right or up, so if you want to indicate the other direction, you would have to put the negative.
And then do you want for the magnitude, do you want it, like rounded to, how many digits do you want? Or-
Probably one decimal point is fine.
Oh,
If you've got more than, if you have more than that,
but
sure,
three.
that's fine.
Okay.
Please make sure you round properly. Some people, too many people, and this is not just this group, just like truncating. I'm going to one decimal place, anything after that I'm ignoring. You can't necessarily ignore that.
For the simulator, or, what's the thing called online that you can basically check that has the voltages?
The simulation?
Yeah, I like to check my answers through that, and when I got the magnitude, the first decimal was one number off for all of them, even like the example one. So I just stuck with my calculation instead of what it told me.
I hope you proudly denounce the computer and any person programming that.
Well, it's like, if it was off on the example, then it's probably gonna be off on mine, so. But it was like, basically instead, I can't remember if it didn't round it, or if it rounded one more unit up.
Okay. I would need to see this specific case just to
Okay.
see if there's another issue, but. So you had, so for example, you said, like in the procedure A, the example
Yeah.
of procedure A, where it had 2.236, the computer would go 2.3?
Yeah, so it only did one decimal, but it always went one up from what I got with my math calculation. So I just put what I got instead of what they got.
Okay.
So, but it was always the first decimal.
Yeah, I would need to play around more with the
Okay.
computer to see if that's a bug or.
I was just wanting to make sure that the computer wasn't right, or if I was wrong.
I don't know.
Okay.
Right. Considering the type of people physicists are, if the computer were wrong, I imagine they've been told, but it's also possible that it was free labor doing it, so it's just a low priority. So potentially when I created yours, I put a mark next to all of those because the computer was right, I don't know. At a break, we could check specifically something that
I
you've
can
done.
pull it up. and
Okay.
read it too.
Other questions? All right. question's gonna be about more than just this lab, so. Yes?
When does
please.
master set 6 and 7 due?
One more time?
When does master set 6 and 7 due?
On my calendar here, I have master set 6 and 7 due a week from today. Now, it's also possible that I changed it from when I wrote it down on this calendar, but that's what I have written down here.
Like the 14th.
Yes, it is. Brittany?
Will you have equations listed on next Monday? Or are we expecting
Okay.
to memorize all those?
That'd be a nice ideal to assume that you have all the equations. I was about to say in memory, but you know, that you know them all. You don't have to memorize them just because it's part of your life. All right, so the equations that I give you, if you look at the old tests, I've been using Hewitt for, I guess, the 12th year I've been using Hewitt. So if you look at one of the old tests, test ones, it should, basically, that's what you're gonna be given. But as a general rule of thumb, the formulas I give you are any of the formulas given in Plug and Chug, and any formulas given in the summary section. That's that one there. So sometimes there's formulas up here, and then there's formulas within the problems. Those are the ones that I typically give. There are a couple of times where the way Hewitt words it, or the letters he uses is different than what I use. So in that case, I try to give both. So it depends upon which set of formulas is stuck in your head. You'll at least hopefully see one that looks familiar. Or if I want to dream big, you'll look at both of them and go, yeah, that's when Hewitt did that, and that's when Dr. Fox did that, so. And then you get to decide which one was a barbarian. Other questions?